Welcome back to my channel. Today I want to have a look at how to find mole fraction and mole percentage of the components of a chemical reaction. I'm going to have two examples in order to be able to complete everything that has to do with mole fraction and mole percentage. Before I continue with this, let me pause the video while you give it a try. Alright, this question is about mixing ethanol and water together in a reaction vessel. We are given 46 grams of ethanol mixed with 36 grams of water. So first and foremost, we have to know the formula of ethanol so that we'll be able to calculate the relative molecular mass, and also the formula for water so that we will be able to find the relative molecular mass of water also. So let's go there. Ethanol is an organic compound with formula C2H5OH. So by calculation, carbon is 12 times 2 at the bottom, plus hydrogen is 1 times 5 below 8, plus, or let me say times 6 altogether because of this one. 5 here, 1 here, making 6, so don't be confused. Then plus oxygen, which is 16. So let's see what that will give us. Okay, that gives 46 grams per mole. So definitely, this is the molar mass of ethanol. Is 46 grams per mole. Don't forget, 1 mole of any substance contains the molecular mass of that substance. Okay, as for water, molecular mass of water, that will be 1 of hydrogen times 2 plus 16 for oxygen. That will give us 18 grams per mole. Okay. Now, the next thing now is to convert the molar masses to moles. Why am I converting to mole? Because I told you we are finding the mole fractions, mole percentage. So definitely I need to take them to moles in order to be relevant with what we are looking for. Okay. The formula that connects molar mass and mole together is this. Number of moles is equal to mass given over what? Molar mass. Okay, so for ethanol, the mass given for ethanol in the reaction is what? 46. Okay, that will be mole is equal to 46 over molar mass of ethanol is also what? 46. It's just a coincidence, okay? That is 1 what? Mole. That's 1 mole of ethanol that is in the mixture. Okay, for water, mole, mass of water given is what? 36 over molar mass of water is what? 18. That will give what? 2 what? Moles. Alright. Once we have found this, we are almost done with the question. So what next? You now apply your mathematical knowledge of ratio. So this is where the knowledge of mathematics will play its role. To find mole fraction The first thing, okay, mole fraction of ethanol will be mole of ethanol over total ratio. And what is the mole of ethanol we got? 1. Total ratio of the mixture. Total ratio of the mixture. Please take note of that. And the total ratio of the mixture will be 2 moles of water plus 1 mole of what? Ethanol. That will be 2 plus 1. That will give us 1 over what? 3. That's the mole fraction for ethanol. Mole fraction of water will be mole of water over total mole. I wanted to write total mole of mixture. So that will be 2 moles, which is for water, over total is 1 plus 2. That is 1 of ethanol plus 2 of water, and that will give us what? 2 over what? 3. So I've answered question 1, which is finding the mole fraction. To find the mole percent, you just have to, when we say percent, it means we are multiplied by what? 100. So for ethanol, that will be 1 over 3 times 100. That will give us 33.3 approximately. And for water, that will be 2 over 3 times 100. That will be the double of this one. That will be approximately 66.7%. And by the time you add them together, it must give you 100%. That is all. Here is another question on mole fractions and mole ratios. But this time around, we are dealing with gases. A mixture consists of 5.6 dm cube hydrogen gas, 11.2 dm cube carbon 4 oxide gas, 2.24 dm cube oxygen gas. So we want to find the mole fractions and mole ratio, mole percent of each gas. How do we go about this? It's very simple. Don't forget the other time, in one of my videos, I said MV means molar volume. And this means 1 mole of any gas. That means 22.4 dm cube represents 1 mole of any gas. It is that I will use as the conversion factor to convert all these things to what? Moles. So 1 mole of any gas is equivalent to 22.4 dm cube. So now, let's now find the mole of each of them. Okay? Alright. So let's assume that, okay, X mole of any gas now will be equivalent to whatever we are given. So, to find the mole of hydrogen, this is the volume of hydrogen given, which is 5.6. So, obviously, if 22.4 dm cube is 1 mole, 5.6 is not up to 22.4 dm cube. That means mole of hydrogen will be 5.6 divided by what? 22.4. We'll calculate that. Mole of CO2, that's carbon 4 oxide also, is 11.2, which is not up to 22.4. That means it cannot be up to 1 mole. So that will be 11.2 over 22.4. Let's see what that is going to give us. Mole of oxygen is also what? 2.24 dm cube. It's not up to 22.4 dm cube. So if 22.4 dm cube is 1 mole, definitely 2.24 dm cube cannot be up to 1 mole. That will be 2.24 over 22.4. Let's do the calculation. Okay. By division, this is what we got. So when we find the total mole, we add all of them together to get this. And to get the mole fraction, we use mole of hydrogen divided by total mole to get this. Mole fraction of CO2, that's carbon dioxide, mole of carbon dioxide divided by 0.85, which total mole, we got this. And for oxygen, this. So if you want to find the mole percent, you just multiply each of them by what? 100. So that will give you their percentage.